Now, just in few minutes, let us understand function, first derivative and second derivative from its graph. Simple as that. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll understand a graph of a function, and from the graph, we'll analyze few points. And that will help us to understand the derivatives and derivatives of derivatives. Clear? The question here is, in the graph of f of x, b and d are the turning points and c is the point of inflection. So b and d are the turning points and c is the point of inflection. Complete the table indicating whether each value is 0, positive or negative, and then use the information to describe turning points and the point of inflection. Correct? So first you have to complete this particular table, writing at point given to you a, b, c, d, e, whether the function is positive, negative or 0, or whether the derivative is positive, negative or 0, or second derivative is positive, negative or 0. Once you've done that, then you analyze the turning points. How will you explain from the information which you filled in what are the turning points, whether they are maximum or minimum, the local maximum or minimum, and then discuss about the concavity and point of inflection. Perfect. So I hope the question is absolutely clear. You can actually pause the video, answer this question, and then look into my suggestions. In case you want to learn from me, then you can always send an email on the address given. Perfect. Many of my students are doing extremely well, getting top grades and scholarships, like Akshat.
After attending university. The winner of this year's Certificate of Achievement Schulich Leader Award is Akshi Kandivani.
Great. Our student Akshat gets highest marks and the most prestigious Schulich Leader Award. You can be there. Join our classes and excel. Okay, so let's begin with the solution of this particular question and analyze each point one by one. So let's first consider the function itself, f of x. This graph is of a function f of x, and the independent variable here is x. So now, at point A, which is right there, we can clearly see that it is below the x-axis, and therefore the point has negative value. Point B, C, both are above the axis, and therefore the function is positive, correct? So you make a sign chart like this, correct? You remember that? And at D, the function is negative, and at E again, it crosses the x-axis and comes to quadrant 1, where it is positive. So first part is over. Now let's look into the derivative. Now what does this derivative indicates? Well, derivative indicates slope of tangent, right? Or gradient, right? So gradient is positive if I'm drawing something like this, right? So tangent is going upwards. Do you see that? It is positive. So at A, it is positive. At B, the gradient will be 0. At C, tangent is going downwards. At D, horizontally, so 0. And at E, it is again rising. So very easy to write down where the first derivative should be negative, 0 or positive. Absolutely clear, right? How about the second derivative? Well, the second derivative gives us the information about concavity, right? Right. So as you can clearly see, we have also given you that C is the point of inflection. So C is the point of inflection means change of concavity, right? Clear? Now here on the left side of C, you see it is concave down. So the derivative is negative, right? So this is down. So, so the second derivative at A also, B and up to C, it has to be negative, right? So at C, it is changing. So C is a typical point where we have point of inflection, a critical point also. And so that gives you 0 as your second derivative. And on the right side, it is concave up. So whenever it is concave up, then the second derivative has to be positive. Is that clear to you? So we got a sign chart, right? So function, you're checking the value, whether it is above or below x-axis, correct? If it is above, in that case it is positive, and if it is below x-axis, it is negative. The y values, right? So that really gives you the y values. Perfect. Now with that in mind, let us now answer the second question, which is about turning points, right? So we need to describe the turning points. So what are the turning points we're looking at? Point D, B and D, right? These are the two turning points. So at these points, when you're describing what should you look at, the key parameter to look at is the first derivative. So first derivative on the left side of D is positive, right? So at A, it is positive, and at B, it is 0. At C, it is negative, right? At D, it is again 0, and at E, it is positive, correct? You can see that derivative. This is what we filled in earlier, right? Right? So I'm just sharing with you, same thing. So that really means that you have a positive tangent here and then negative, correct? So when the function is increasing and then decreasing, you hit the maximum. We call this as the local maximum, correct? So at B, I should say, at B, we have local maximum. The reason is that the derivative changes from positive to negative, correct? Now, if you look at E at D, this point, right? So here, the derivative is negative on this side and positive on the other side, 0 definitely at D. So the derivative shows very clearly that at point D, we have a local minimum, right? Since the derivative changes from negative to positive, you get the idea, right? So that is how we figure it out. And of course, these points are the turning points because the derivative itself is 0, right? So we have to analyze left side and the right side of this critical point, right? And if it is changing from increasing to decreasing, we have hit the local maximum. And if it changes from decreasing to increases, we have hit the local minimum. Perfect. I hope it is absolutely clear, right? Well, you can always contact me on the given email address in case you directly want to learn from me. Perfect. Now let's talk about concavity. Perfect. So concavity, we are actually analyzing the second derivative. So we figure out that the critical point is the point of inflection C, where the concavity is 0. So, the second derivative is 0. On the left side, we say that the derivative is negative since it is concave down and is positive on the right side since it is concave up. So, definitely, we have an interval which is from minus infinity to 0, right, up to C, when it is concave down. And then from 0 to infinity, we see that the graph is concave up. So at C, the concavity changes. And therefore, we have a point of inflection. Perfect. So that is how we describe it. So I hope with this small video, you got the complete concept of, from the graph, how do we analyze a function? Normally do it with a sign chart, writing plus and minus. How do we analyze the first derivative that gives you local maximum minimum, and the second derivative which gives you concavity along with point of inflection? Point of inflection is the point where the concavity changes. Perfect. With that, we end this video, and I hope you find it interesting and useful. Feel free to write your comments and share your views. If you like and subscribe to my videos, that would be great. Thanks for your time and all the best.